Hi, my name is Ailie, and I'm a research engineer at Adobe. Today I'll be presenting some work that was done during my PhD at UC San Diego in collaboration with Adobe Research, and this was also a demo at last year's UIST. People often seek help online while using complex software such as iMovie, Excel, WordPress, and many others. But the help that we find on the web lives in a totally separate world from the software being used. And as a result, searching for help requires us to switch our mental context, visual attention, and input focus away from the task at hand and onto the task of creating a search query and browsing results. Now, prior work has shown that embedding help search in the application, like Blueprint did, or using application context to improve the relevance of online search results, like Intertwine did, can help people find what they need more easily and more quickly. And recently, our own prior work called Replay explored these strategies for embedding video assistance in context. But all of these strategies are only effective if you actually search for help, and people don't always search when they need help. As other prior work, as well as our own work on Replay has shown, people don't always know when they're using a suboptimal strategy in software, and even when they do know, they might be hesitant to switch context and take their attention off of what they're doing to search for help. And part of what makes this context switching so difficult is having to come up with the right terminology to use in your query that will get you the results you want. Now, in contrast, the ideal way to get help might be to have an expert sitting right beside you who knows your exact context and situation and can give you direct assistance. And in these cases, people can use language as well as gestures and their shared contexts to communicate effectively with each other. And we know from prior work that language and gesture are both extremely powerful and often complementary to each other. We often use both together when speaking. And one of the earliest technical examples of this is from 40 years ago, called Put That There, where here Richard Bolt uses what we call deictic gestures or pointing to refer to ships and locations.
Put that there.
Now, the use of these deictic references can be very powerful for spatial or visual tasks like this one, because it's easier to describe things by pointing at them than by using only words. So in this work, we wanted to see how we might bring these benefits of multimodal interaction and input to help seeking. And we hypothesized that moving these search tasks into a different modality might help people stay focused on their tasks while they search for help. So to address this first question, we built ReMap, which extends our prior work on Replay and enables three main multimodal features to make help search easier. The first is using speech to initiate and dictate a search query. The second is using speech to also navigate the videos that come back from a search. And finally, deictic resolution, so being able to point at interface elements to include them in your query. So here's how the first one works, using speech to initiate and dictate a search.
The user can search for help by saying, "Search," followed by their query.
How do I make a text shadow?
When the user is finished speaking, ReMap initiates a search.
And second, the user can also use speech commands to follow along with the videos that come back from their search while they work on the task itself.
Play second video. Previous marker. Pause. Play.
And finally, users can make deictic references by clicking on elements in the software they're using and referencing them with the words this or that. And ReMap will automatically add those names of those elements to their search query. And this can be especially helpful for software that has a lot of technical domain words that might be hard to remember.
Search. How do I use this?
So in this example, ReMap changed the word this to the word noise reduction and equalizer when the user clicked on that tool. Now, in order to figure out the names of the elements that the user is clicking on, ReMap uses accessibility APIs, which means that ReMap can work alongside any desktop or web application as long as it has accessibility labels for its interface. Now, to incorporate speech interaction, we built a server-side application that communicates with the web speech API open in a browser window using JavaScript. And to play the videos, ReMap embeds 5 video players for the search results that come back, and our web server communicates directly with them so that the user can use the speech commands to also control video playback. Now, to address our second research question of whether multimodal search can help people stay focused on their task, we conducted an exploratory Think Aloud lab study with 13 participants. And participants used Canva, which is an online graphic design software. And they were asked to choose one of these 2 designs to recreate as closely as possible, and were asked to use ReMap to search whenever they needed help. And we included several elements in both of these designs that were not the most straightforward to accomplish in Canva to raise the chances that people would need to search for help during the study. Our main findings from the study were that people found ReMap useful for multitasking, which meant that they were able to focus on their task while searching for help at the same time. People varied in their preferences for navigating videos, some preferring to click on them manually, while others preferred using the speech commands. And people mostly used the Deictic resolution feature for referring to elements on the canvas, as opposed to tools or buttons in the interface. So regarding multitasking, what I mean by this is participants would work on their task in Canva while searching for help and playing videos at the same time, which is exactly what this clip I showed earlier demonstrates. Many participants had very similar behavior to this, following along with the videos and speaking commands when the video got too slow or too fast. And for this, the timeline markers, which are these little green dots on the timelines of the videos, were especially useful. Participants could use speech commands to go back and forth between them, and this made it a lot easier for people to back up or fast forward to a reasonable point in the video without having to specify exactly how far to go. Now, most participants seem to exhibit a preference for either navigating the videos manually by clicking on them or using the speech commands. For those who preferred the manual way, they had the advantage that was also built into ReMap, where if you hover over these timeline markers, you see a little preview of the captions. So the people who preferred the manual way liked being able to hover over these markers and see what they were going to be watching before they actually clicked on it. On the other hand, people who preferred speech mentioned that they liked being able to follow along with the video and keep it at the same pace as them. So this participant said, if I hear the info I want and I'm kind of following along, I can pause it, take the instructions, apply it, and then continue watching, all without having to stop the fluidity of the work. And these varied preferences highlight the importance of providing both options in a multimodal interface, especially as people's needs might change depending on their particular task or environment. And finally, the Deictic resolution was mostly used for referring to Canvas elements. Overall, 22% of our spoken queries included a Deictic reference. And we think it's possible that Deixis wasn't as useful in Canva as it might be in other more technical software, because the terminology in Canva is relatively straightforward. Most of the elements you're using are images, text boxes, graphics, and that kind of thing. So in this study, people tended to use it more for convenience, referring to things without having to say the full name. And most of the Deictic references made were for Canvas elements, such as images or text headers and that kind of thing. Unfortunately, only a quarter of the references people made were successfully resolved to the correct term, mainly due to missing accessibility labels in Canva. I think one thing that's exciting about this work is that we showed how you can leverage accessibility to achieve this system-wide multimodal support. But of course, this only works as well as the accessibility labels themselves. So if application developers don't implement labels for all of the inside elements of their applications, ReMap won't be able to leverage that. As an example, most of the references that were unsuccessful in our study were referring to a chart or a graph on the canvas. And Canva doesn't have an accessibility label for charts and graphs. In general, accessibility labeling tends to be more common for the widgets or tools or buttons in an interface, and is more rare for the insides or the actual documents or canvas items that the user is manipulating. And future work could address these challenges or limitations by using other methods to detect what the user is looking at or clicking on, such as computer vision. But we also think that a system like ReMap might work better on mobile systems where accessibility labeling is more strictly enforced. And during the study, we also encountered a number of usability challenges that we think could be improved in future work, many of which echo similar findings from other work on voice search. For one, ReMap uses the web speech API to automatically detect when the user's done speaking, and then it issues the query right away. But some users in our study would pause to think while speaking their query, and the system thought they were done, which caused some frustration, as it sent the query off early. And like many mobile voice assistants, this automatic detection of when you're done speaking can help make the interaction smoother and more efficient. But for cases like this, where users are trying to describe a problem in more detail, it might be better to have them explicitly press a button or say a keyword to indicate that they're done and that the search should be initiated. Second, correcting and editing mistakes in speech queries is a known difficult problem that several participants encountered during the study. This could be either speech recognition errors that the system got wrong, or the user deciding that they want to rephrase their query. To correct them in our study, people either switched to typing to type a correction in manually, or they repeated the entire query over again, or in one case, a participant actually repeated themselves in real time, which resulted in a very long and redundant query. And future systems could support more natural ways to correct oneself, much like you might do in conversation. For example, by repeating just a subphrase that you want to correct, or saying something like, change this word to that word. Next, as the videos showed, ReMap displays each word in real time while it is transcribed. And while this can be useful and is often a feature of mobile voice assistants such as Siri, in ReMap's case, it sometimes distracted participants because they were trying to keep their attention on the software to make deictic references and refer to their task, but they instead found themselves looking at the transcription in ReMap's interface while it was appearing. So in this case, it might be better to wait to show the entire query once it's been fully transcribed. And finally, as we saw, and as prior work has also shown, users tend to describe actions that they want to do in their search queries, as opposed to specific tools that they want to use. And an open question for future work is, how might we better support this and still help users describe these actions using the right terminology? Perhaps by augmenting users' queries with additional vocabulary that's related to what they're saying could be one way to accomplish this. So finally, here are a few things I'm hoping you'll take away from this presentation. Multimodal help seeking can help people stay focused on their task while simultaneously searching for and navigating relevant help resources. Specifically, using speech and pointing for in-application search seems to be a promising approach for helping people communicate their questions in a more natural way. And finally, our system ReMap introduced an initial approach for multimodal contextual help search that we hope future work can build on, and we hope that our findings and recommendations that I've shared with you today can help inform the design of future multimodal systems. So thank you so much for listening, and a big thanks to all my wonderful collaborators.